Before my talk, I'd like to thank to the organizer ISO's conference, especially for Dr. Monica for calling me. Well, my title is following, slightly far from the degradation issues, but evaluation is one of the key for figure out the characteristics of organic photovoltaics. Yes, before the overview, before the evaluations, I want to show something. Here is a definition of the standards, something philosophical expressions. The standard is needed for industry, especially for calibrations. What does it mean? The standard is the certified reference materials. Please consider, imagine. I just picked up 3 devices. For evaluation of the weight, yes, we have standardized kilogram weight. Length as well, the meter standard is there. For photovoltaics, solar cell, yes, we have primary solar cells. There are 4 units in the world. 1 in USA, 1 in Japan, 1 in Germany, and the last one is in China. From this primary solar cell, we define the secondary primary solar cell in the IEC protocols. But still, there are no problem. Yes, for crystal silicon solar cell, there are standard solar cells, primary solar cells. Amorphous silicon solar cells as well. But we don't have standard organic photovoltaics, OPV. I know for daily use, we calibrate the silicon solar cell, standard solar cell for OPV. For daily experiment, that's sufficient. But theoretically, it's not sufficient because suppose there are 2 types of the solar simulators. One is the solar simulator A, slightly higher at the visible range. The other one is higher for IR range. Both of them gives us same irradiation levels, 100 milliwatt per square centimeters, carefully adjusted by the crystal solar standard solar cell. But the difference comes is very huge. Of course, solar simulator A gives higher performance theoretically. Another issue is there. Yes, there are different testing protocols and also deviations. This was announced in 2010, 4 years ago. The most of the community, ISO's community members are committed in these activities. And that, unfortunately, at that time, Japan was not involved, but now we are involved in this kind of activities. It's already open, disclosed the data. There are huge distributions for photovoltaic parameters. The conversion efficiency, the error reaches for 60% for maximum. I think it's nothing surprising. The error mostly comes from the error from the ISC. Yes, I just express the detail furthermore. I just pick up the very dominant testing centers in the world. They have different philosophies how to evaluate the solar cells. The USA believe the solar cell itself because they have full fine days every year, no cloudy. They don't need to take care about the diffused light by cloud. In Japan, it's impossible. That's why we believe we constructed very fine, accurate solar simulators. In German, PTB, they thought a lot and created very fine algorithm to evaluate to calculate the spectral response by so-called DSR method. I tell you the details later. But in any cases, there are different sources for primary definitions. But we have standard solar cells. That's why finally we can reduce the mismatch in case of crystal silicon solar cell. Here in Japan, its problem is there. The ICE, the testing center, suppose we ask the evaluation of the organic photovoltaics. They received, and they try to utilize the references, spectral matching, to tune the spectral matching of the solar simulation, and so on and so on. Finally, they tell me, okay, let's come back 3 months later, or sometimes more, 1 year later, please come back to evaluate the, how much the performance it is. We cannot wait so much. Yes, I want to tell another things. Solar cell was the performance was defined IEC 96 something, and very carefully, but only limited under the one sun conditions. But please imagine the OPV, half of them may want to utilize inside the applications. This is one example. Sorry, not OPV, but the DSSC. They plot the conversion efficiency reached 26%. It's not wrong because they are using the light source for fluorescent light, not solar simulators. If we change the light source, the conversion efficiency changes, of course. Moreover, the light intensity affects the cell performances. At the lower intensity, like 1/10 or 100, lower intensities, in case of DSSC, cell performance slightly goes up and come back again. But the crystal solar cell the efficiency drops down very drastically. That's why I want to emphasize the organic photovoltaic, especially suitable not only for outdoor test, but indoor or side wall of the buildings. This is one example. Suppose there are 9.89% of the DSSC is there. Under the 1/10, 0.9 sounds, the cell performance goes up. Easy to remind. Yes. Now, yes, the LED solar simulator becomes more practical. I want to show something. Yes, this is our system with approximately maybe 50 bulbs of the LED lamps with collimator lens systems. All the bulbs are focused on only one areas to give homogeneous and very strong intensities. This is operation touch panels. We can tune any kind of curves for wavelengths. Also, we can tune the intensity as well. Very flexible. And for our request, I requested the cell system to define only 400 to 800 nanometers for visible range. And the spectral mismatch is very accurate within the 5% errors. There are there are limitations, I'm sorry. For this system, it's tunable from 350 to 1300 nanometers. Now it's available. Moreover, the uniformity should be taken into account. In our case, within these areas, the error could be minimized 5%. There are no limitation for size, and already available in industry. Some company has already using for OPV, for meter size, for example, 600 millimeter by 1600 millimeters. Finally, how it will be? Yes, we compare the crystal silicon solar cell, the polycrystalline silicon solar cell, and DSSC, for example. The 9% of the DSSC gives the 70.5% under the LED, the limited areas, because DSSC works very well. IPC reaches over 90%. That's why, if we limit the light source from only for visible regions, the cell conversion efficiency goes up. This is same trend in the OPV. Okay. So I just summarize the problem issues. There are mismatch, so because of the so much reasons, and yes, we need we want to evaluate not the STC standard testing condition, but under the fluorescent light or under the weak light source. For this purpose, DSR method is one of the options. DSR method was announced in 1986 in Germany by PTB, and since then they've improved a lot. They modified and improved, and I now recognize it is coming to the third generation something. Okay, we followed this kind of trend, and this is the protocol procedures. Oops. This is the main unit, almost equivalent with IPC machine. We evaluate and accumulate the IPC curve with different intensities. And finally, we figure out how the solar cell respond to the limited areas, the light source. And then we give the data from here to this unit, and evaluate the solar simulators intensities, and compare for two levels. And finally, we can define how much we should tune, calibrate the intensities. And after that, we can evaluate the OPV by these solar simulators. Okay. Yes, this is the same theory. We accumulate and evaluate with different intensities up to 100. This is the unit for spectral reference cells. No, used to be we called, maybe we can recognize a kind of virtual standard solar cell. Okay, this is the theory back behind, but I don't want to tell too much details. We evaluate the IPC, ISC with different intensities. Sometimes the spectral shape changes with different intensities, like this, and accumulate how it works, our solar cells. This is one result for linear response crystal solar cell. Yes, in this case, we just compared the standard crystal solar cell with DSR method, the red one, and both of them gives better accuracy within 3%, of course. But in case of non-linear crystal solar cell with lower intensities, the standard crystal silicon solar cell cannot give the clear answer because the error mismatch becomes much higher, over 25%. But the DSR method gives the very fine, very accurate values. And yes, in case of OPV, yes, I recognize this is non-linear type of the solar cell. with different intensities. And in our case, in our machine, we can give the error within 5%. I think good enough. And in case of DSSC, this is also a tricky device with non-linear response. We could minimize the error within 1.7%. Of course, theoretically, we can evaluate the LED response by giving the curves as a theoretical data, and it gives the clear tendencies within the 3% errors. Okay, finally, in this case, I mean, I claim to the iced because it takes time, but theoretically, in this case, we can give the absolute performance within a half days. Okay, furthermore, this is just pictures. The device is Perovskite solar cell. We load 4 lines, 2 for current, 2 for voltage. We fix on the base. This is a flat type thermocouples, and thermoconductive sheet should be laid down. And we stack one by one. Also, here is a protecting mask to fix the areas. We have so many variations for photomasks with different size. Yes, within the with difference of the 0.1 millimeters pitch. Some of them square, some of them are square. And we calibrate the areas by CCD cameras by using primary scale because edge is rounded. And finally, we cover everything to avoid the black tape blackout, to avoid the reflectance and scattering. And we fix on the base here. We monitor the temperature, we monitor 3 temperatures. One is the oven here. The other one is the unit for controlling the temperature device. The last one is the thermocouple under the photovoltaics. We always monitor and control the temperature and arrange minimize the error within 1 degree C. And finally, evaluate with very accurate 2 light source type of the solar simulators. Thanks for Kanagawa Academy Science of the People. Now they are starting to give a kind of certificate especially for organic photovoltaics. For perovskite solar cells, it's very tough work. Of course, there are hystericity issues, but additionally, the starting voltage affects the IV curve. Also, I know the light soaking before the evaluation affects the IV curve. The temperature greatly affects the IV curve. That's why we have to consider a lot. Okay, I think I have five minutes maybe. For assembling the modules, maybe for this is serious for durability issues. This machine was originally designed for DSSC. Maybe movie is more easy to understand. Yes, we roll the orange tube. There are sealant with acrylic resin. We draw the line outside, and here is a nozzle. Because I'm sorry, this is DSSC. We give the droplet of the electrolyte, and after that, we put into the chamber over there. We use the vacuum systems. This is the upper substrate, photoanode, and fixed on top. And the lower substrate are fixed on bottom. And finally, this close the chamber to evacuate the air. and press face to face. And finally, we give UV light to cure the resin. Yes. And the device comes out. So by this approach, we are free from the end for drilling the hole for DSSC. And yes, we have so many variations. We can construct a very tough, reliable device with, with perfect sealing. We have so many options for design, the color, transparencies. Even for plastic substrate, we have already done by this machine. Yes. The last year, President Hollande in France visited our Japan. That's why I gave a present gift to him. And this year is special for Professor Gretel. I expect 2 days later we have the, I don't know, I expect the Nobel Prize will be given for him. I don't know. Okay. The Perovskite solar cell was also assembled by this. Okay. She was extremely happy. This is the first trial.
Excellent.
Just 1 month. I'm sorry. The performance very poor because there are leakage. Maybe the short circuit was there, and there are bubbles for dots. But anyway, we are on the way. I think, long-term stability for smaller pieces. Suppose we expose under the dry conditions, it survives over 2 weeks with over 15%. I think good enough. This is not continuous irradiations, just keeping under the dry conditions. I think it's time to conclude my talk. DSR is unique and maybe a good approach to evaluate the absolute performance for OPV, and acknowledgement for funding. Thank you for your kind attention.
A very interesting talk and updating us what are you doing in Tokyo University. Now we have time for 1 or 2 questions.
When you measure external quantum efficiency or spectral response at different intensities,
yes,
you ever see sublinear behavior? So the spectral response decreases with increasing intensity of light, yes?
Almost, yes.
Yeah.
Any other questions?
So for your LED light, so when you use your LED light to measure the efficiency of silicon solar cell, there is no big difference. Why in DSSC such a big difference? For
For crystal silicon solar cell, the standard, the secondary solar cell is sufficient to fix the intensity of the solar simulator.
For your DSSC, I think the efficiency was, the difference is 9 point something to 7.9%.
Yes, yes, yes.
So why it's so high with your LED sum simulator for DSSC? I mean the efficiency 11.9.
Okay, it's very easy because the DSC, the spectral, the range is limited only for 400 to maybe 65, 650 nanometers. We don't need the IR. DSSC cannot apply the IR range. That's why we just losing that energy. That is the main reason. DSSC are losing half of the energies. OPV as well. Yeah. Yes, please.
In your system, do you have a standard solar cell for the measurements?
Standard cell for?
Yeah, yeah. I mean, a source
Yes.
a light source, a standard solar light source for your measurements?
It depends. For STC conditions, standard testing conditions, maybe generally we use halogen lamp solar simulator.
But yeah, but this solar cell has this solar this light source has these huge peaks in several places in the spectrum.
Yes, it is.
And there is no relationship with the real spectrum of sunlight.
Yes.
And then you are talking about standards, and the source, the light source, is not standard. I should think it's not so similar with the
it depends
solar
on the
spectrum.
Yes. It depends on the accuracy. If it is serious, we need sometimes we want to need a certificate. We try to use the two light source solar simulators. And if we want to, not the certificate, but we want to figure out the low light intensities, we use the LED lamp. It depends on the requirement, maybe.
Yeah, thank you very much for your answer. Let's thank speaker again.
Thank you very much.